This is a re-recording for the third problem for 2022. And the reason why I'm re-recording this is because unfortunately I made a very, very wrong mistake solving mesh analysis. I happened to get the right answer in the end, but the process was wrong. So I thought it was big enough to warrant that I re-record question 3, going through how to solve it once again. Because if you followed the process that I had written, you would have gotten it wrong. And the only reason why I got it right is because I made a second mistake fixing the original error. So let's start with solving the mesh analysis. The first thing we want to do is draw our currents. So let's draw our currents like such. The convention that we usually do is clockwise, but if you do all of them counterclockwise, you'll get the exact same answer. You can actually mix and match directions, but we don't recommend that because, well, I don't recommend that, neither do the professors, because you overcomplicate the solution. So just keep it in one direction. In our case, we're going to go with clockwise. If you decide to do counterclockwise, you will find that all of your currents are 180 degrees from mine. And that will be correct because, again, that's just the opposite direction. The second thing we want to do after drawing our mesh, our directions, is seeing if we can create a supernode or a super mesh. Recall that a super mesh in mesh analysis is when two currents share a current source, like so. And we do, right here, right in the middle between I3 and I4. This greatly simplifies our equation. So remove these, and instead, draw a big super mesh. This is going to be our super mesh. So let me just take a picture of this so I can leave it to the side. And now let's create our equations. For our first one, I1, let me actually just take a picture of this and put it to the side so you can also see. Like so. There you go. So for I1, you can start at any point in the mesh. So let's start here, for example. Let's start here. So we have a voltage drop of the resistance 2J, I1 minus I2. Recall this is shared between I1 and I2. So the current going across is I1 minus I2. And recall this is V times R. That's I. Or sorry, this is R, this is I, this is V. I mix them up. So now we continue on in our circuit to our next item here. And we can actually combine these two here into a single equation. It simplifies our equation. So this is going to be a voltage drop of 8 minus 2J, or 8 plus 2J, I1 minus I3. Recall, even though we have this super mesh, this area here is I3, and this area for here is still I4. So we continue on in our circuit until we hit the voltage. Now, recall how voltage sources work. If you come out the negative end, it's going to be negative. So we do subtract 10 with a phasor of 45 degrees is equal 0. Then we finish it off. This was a mistake I made in the previous recording. I had flipped all of these signs to be pluses. This isn't like passive and non-passive mode. This is just a this is how you do mesh analysis when the voltage is, when you're coming out of the negative end of a voltage source. It's all going to be negative. And all of your impedances are going to be voltage drops. So that's our I1. Likewise, if this was the positive end and this was the negative end, the only thing that would change here is this sign. This would be plus. because you're coming out of the positive end now. So now let's go to I2. Now I2, we actually have all of our work done for us because we actually have a current source that's not shared with another current in our I2. And that's going to be our current, because the current source is going to give out as much current as possible to, or as much voltage as possible to keep that current, like so. So I2 is just going to be, actually, it's going to be negative 3 with a phasor of 60. Recall that, again, we're going against the current source, right? The current source pointing up, but our current, or our mesh, is pointing down across the current source, so we negate it. After that, we don't have to do anything. That's it. That's I2, because we already have our current. So now it's time for our super mesh, I3 and I4. So we start at any point on our super mesh. Let's start here. And again, we could do this trick where we just combine two of the impedances, because these are both just I3. They don't share it with anyone else. So this is going to be minus 2 minus 4j I3 minus, and we can combine these two impedances again because they both share the same current. This is 8 plus 2j I3 minus I1. We come across again to this, and this is going to be minus 5j I4, because we're now in the I4 area, not the I3, minus I2. And then this here, that's just going to be 6 I4 is equal to 0. There's nothing else. So that's all you have to do to assemble a mesh analysis equation set. Now we need to get our fourth equation from our super mesh that relates I3 and I4. Because again, we have 4 unknowns, we need 4 equations. And here, this is where the super node, or the super mesh, comes in. If I draw out this current source coming down here, so this is going down, and here's the wire. This is our I3, and this is our I4. If we draw, if you look up here to our drawing here, this would be I3, and this would be I4. Again, I4 goes up, I3 goes down. And so, we can relate that the current in this wire, is this this current source, which is 4 with a phasor of 0. And the current is also going down, I3 minus I4. And so we combine these two equations. We have 4 with a phasor of 0 is equal to I3 minus I4. Remember that this this current here is the one that's agreeing with the current source, so to speak. If this voltage source happened to be flipped like this, going up, we would do I4 minus I3. Oop. But it's going down, so I3 minus I4. And 4 with a phase of 0 is I3 minus I4. We can simplify this further to just isolate for I3. So we're going to write down here 4 with a phase of 0 is equal to I4, plus I4 is equal to I3. Actually, let's isolate for I4. You'll get the exact same answer either way, so don't worry about it. So I3 is equal to negative I4. We can flip that around. So I3 minus 4 is equal to I4. Let's rewrite that. If you want to, you can also get rid of this phasor 0. Anything with a phasor 0 is just the real component. You can put that in your calculator. 4 with a phasor 0 is just 4. So again, you can isolate for I4, you get the exact same answer. Don't worry about it. Now we have to simplify our equations. Let's take our first equation down here. And let's start simplifying and expanding. So we're going to have here, the first step we do in mesh analysis, we distribute. Here, here, and this is constant, so we just leave that for now. So first step, distribute. Let me write that. So it's going to be negative 2j, or negative 2j, I1. That gets distributed there, so that's going to be plus, let's distribute this negative in first, just so we don't mess it up. So it's going to be 2j, I1, and that's going to be minus 2j, I2. Let's distribute this one out. That's going to be negative 8 plus 2j, I1, plus 8 plus 2j, I3, minus 10 with a phasor of 45 is equal to 0. So again, make sure to account for this negative sign. I'm a forgetful guy, so I always forget to do that. And now, the second step here, so this is 1, distribute. Second step is substitute. We know from the equations up here that I3 minus 4 is I4. So we're going to replace any instances of I4 in here. There are none, so we can skip that step. And now let's substitute all I2s in here to negative 3 with phasor of 60. So that's 2j, I1. Let's put that in brackets actually, just so it's very clear. Minus 2j, 3 with or negative 3 with a phasor of 60. Minus 8 plus 2j, I1, plus yada yada yada. It's the same thing. The rest is the same. You know, let's just write out for completion sake. Plus 8 plus 2j, I3, minus 10 with a phasor of 45 is equal to 0. If you had isolated for I3 instead of I4 up here, you would replace I3 here. But we isolate for I4. So again, you'll get the exact same answer. Just the process slightly different. And now the third step is combine or collect. We are going to collect all of the terms for I1 and I3 on the left, and all of the constants on the right-hand side. So let's do that. Let's collect I1 first. So 2j, and let's cross that out so we know for a fact that we did collect it, because I've had issues where I forgot to collect or I double collected. Yeah, it's a lot of numbers. It's very easy to lose track. Here we have negative 8 minus 2j. Remember that negative distributes out. That's why the brackets are very important in rectangular form. Alright, so that's I1. That's all of I1. Now let's collect I3. So we only have this one. 8 plus 2j, I3. And now let's move the constants to the other side. So this is going to be 2j, negative 3 with a phasor of 60 degrees, plus 10 with a phasor of 45 degrees is equal to 0. And now we can combine, we can now like simplify. Let's simplify. That's your fourth step. That's it. Every single time when you have a mesh thing, you're going to go through these 4 steps. You may have to skip one, because it wouldn't change. But those are the 4 steps. Distribute your numbers, substitute any knowns, collect them, and simplify. So we can see here that these two cancel out. So that's going to be negative 8 I1 plus 8 plus 2j I3 is equal to, and now let's put this into our calculator, 2i times negative 3 with a phasor of 60. Okay, so when you put a negative phasor into your calculator for the 991 ES, if you put this in, you get an error. That's because I think it's because they think you're making a mistake. So they want you to be very clear about it. You have to write negative bracket 3 with a phasor of 60 degrees. This will get you 3 with negative 120, if I'm correct. Yeah. So, yeah, make sure that that is how you're writing the phasor forms, or else if you just write like this, you will get an error. So, 2i, or 2j, times negative 3 with a phasor of 60, plus 10 with a phasor of 45 degrees. Make sure your calculator is in degrees as well. And you will get, oops, let me put that into, let's leave it as rect form. 12.27 plus 4.07j. If you want the polar form, let me put that into polar form. That's 12.93 with a phase of 18 degrees. 18.4 degrees. Same. Let's put that underneath so that's also pretty clear what's going on there. So this is our first equation simplified. I'm mainly going to be using rect here just because it's, I think it's clear, but again, it's entirely preference. You will get the exact same answer. So I2 is already solved. It's right there. Now the super mesh. Let's simplify our super mesh. Okay, so let's simplify this. So, again, first step, distribute. Let's move that down. 1. Distribute. So this is already distributed, so we can just copy that over. Let's distribute this out. So you're going to get 8 plus 2j I3 plus 8 plus 2j I1. Let's distribute this out. So you're going to get negative 5j I4 minus or plus 5j I2 minus 6 I4 is equal to 0. Second, substitute. So our, what do we have here? This. Let's copy this down. We also, do we have I2? We do have I2, so we're going to have to substitute that in as well. Let's grab our I2 here, copy, paste. So these are our 2 substitutions. So the I3 isn't going to be replaced here. Oop. Negative 2 minus 4j I3 minus, actually let's collect this. No, let's stick with the process. Just stick with the process, you'll get right. Plus 8 plus 2j I1 minus 5j I3 minus 4. So let's see here. Yeah, I3 minus 4 plus 5j negative 3 with a phasor of 60 minus 6 I3 minus 4 is equal to 0. That's a lot. Now, the third step is collect, but here's the thing, we can't really collect when some parts aren't distributed. So we are going to distribute again. So this is going to stay the same, this will be the same, this will be the same. I'm just so lazy, I'm just going to copy paste that down here. Let's remove the part that we need to distribute out. So all of that's the same. Now we have negative 5j, I3, or this is going to be plus 5j, 4, plus, this part is unchanged, 5j, negative 3 with phasor of 60 degrees, minus 6i3, plus 4 times 6. What's 4 times 6? Oh no, I'm too stupid. 24. So here's our substituted equation. Now we can move on to step 3. Collect. That is collect, right? Yes. So let's start with I1. 8 plus 2j. Is that all there is for I1? That is all there is for I1. So I1 is that. Plus, now let's do I3. Negative 2 plus 4j. Remember that negative sign gets distributed in. Negative 8 minus 2j. So those two get taken. Oops, I closed the bracket there. Negative 5j minus 6 I3. And now all of the constants, that's everything that's remaining, goes to the right side. So that's going to be, let's see here. Negative 5j times 4 plus, or this is going to be negative 5j, negative 3 with a phasor of 60 degrees. That's taken. Minus 24. And now we simplify. So I1 is already simplified. 8 plus 2j. I1 plus minus 2 plus 4i minus 8 minus 2i minus 5i minus 6. Oops. You get negative 16 minus 3j is equal to negative 5i times 4 minus 5i times negative 3 with a phasor of 60 degrees minus 24. You will get negative 37 minus 12.5. Actually, this is negative 36.99, but close enough. So now we have our two equations. So we have this, and we have this. This is number 4. Now let's use Cramer's rule to solve for I1, I3, and I just realized there should be an I3 right there. Oopsies. Okay, so let's take these two equations down here. Oop. Like so, and now let's assemble our Cramer rule. So that's going to be this matrix here. This is I1, this is I3, is equal to yada yada. So this is going to be equation 1, this is going to be equation 2, this is going to be I1, and this is going to be I3. So equation 1, I1, that's negative 8. Is that right? Let me check. That's correct. Negative 8. I3 is going to be 8 plus 2j. Equation 4, this is equation 4, oops. I1, let me just... I1 is 8 plus 2j. And negative 16 minus 3j. And now this is our equation parts, or this is going to be our equal parts. So it's going to be 12.27 plus 4.07 j. And this is negative 37 minus 12.5 j. Now I'm just going to give these letters so that I don't need to repeat them. It's A, B, C, D. That's going to be X, and it's going to be Y. Hint, you can put in numbers onto your, if you have the 991 ES, you can put in numbers onto variables, so you don't need to keep on writing them out, and it's incredibly useful in Cramer's rule. So, remember that delta, or the determinant, the main determinant, I guess, is going to be the determinant of AB, CD, which is AD minus BC. Determinant 1 is going to be, you replace the first column with the equal part. So that's xy, and it's going to be bd. So that's xd minus by, crisscross applesauce. And let's draw delta 2 over here. Delta 2, exact same thing as delta 1, but we replace the right column instead. So this is going to be AC as normal, and the right column is going to be x and y, which is going to be AY minus XC. Let's do that out. So it's delta 1, and delta 2. So delta, I'm just going to save you the effort of all of that. Let me just copy it down. Well, magic. There you go. It's just multiplication. You can figure that out on your own. So I1, or the first column here, is going to be delta 1 divided by delta. Let's put that into our calculator. So we get 87 plus 72 I. By the way, I've rounded the determinants. I play fast and loose with rounding. You probably shouldn't, but I'm lazy. So 68 minus 8I. You should get the around same answer anyway. Let's put that into polar form, because currents and voltages we measure in polar form. That is 1.65 with a phasor of 46.3 degrees. Now I3, that is our second column here, is going to be the second determinant over the determinant. So let's put that above. That's 206 plus 43I. And we get 3.07 with a phasor degree of 18.5 degrees. So we already know I2. Let's actually just put it into, let's see, negative 3 with a phasor of 60. Put that into polar form. That's 3 with a phasor of negative 120 degrees. And I4, again, it's just this equation. I just brought the negative in. Just do it on your calculator. I4 is going to be I3 minus 4. So that is 3.07 with a phasor of 18.5 minus 4. And I've got to put it into polar form. That is 1.46 with a phasor angle of 138 degrees. And that is our currents. And we just did the entire basically the entire question, yeah. Those are our 4 currents. I1, I3, I2, and I4. Let's show that in multisim just to make sure. I have multisim open here. And again, you will notice that all the currents, all the voltages are 2 times what you'll expect because multisim measures peak to peak, not it measures peak to peak, not 0 to peak, not just peak. So you just have the multisim values by 2. Unfortunately, there's not an easy way, as far as I'm aware, to measure uh, the phase angle. But chances are that if you get the correct peak answer, if you get the correct magnitude, you've gotten the correct phase angle. So let me just show that. If you put into a calculator 3.3 divided by 2, you get 1.65. There you go. Let's see I2. That's 5.98 divided by 2. That's just 3. You should, there you go. I3 on the bottom here, the bottom left, 6.16 divided by 2. That's 3.08, 0.01 off. And 2.88 divided by 2 is 1.44. There you go. So, thank you for watching this, and I'm sorry about having to re-upload this and redo it because I made such a major mistake. If you really want to know the major mistake, I think I already said it, is that I did this as negative, and then I just added all of the impedances instead of subtracting them, which is very, very, very wrong. So, that's it.